This video will cover Chapter 2, Sections 2 and 3. This video covers translations and reflections. The standards that this video aligns with are 8.G.1, 8.G.2, and 8.G.3. The objective of this video is to verify and describe properties of translations and reflections. Translations and reflections are forms of transformations. A transformation changes a figure into another figure. The new figure is called an image. Our first transformation is a translation. A translation is a transformation in which a figure slides but does not turn. In this, every point on the figure moves the same distance and in the same direction. So here we see the red figure slides over to form the yellow image. The red is our figure and the yellow is the image. Let's go ahead and apply this information. We're going to tell whether the blue figure is a translation of the red image. So, we see that if we take the blue figure and slide it to the right, and then slide it up, we would get the red image. There is no turning involved in this. So this would be yes, this is a translation, because we see no turns at all. Now let's tell whether the blue figure is a translation of a red figure. Here we see that no matter which way we slide it, up, down, right, or left, this cannot create the red image, because the only way to gain the red image is if we turn it. So this would not be a translation because it turns. Translation is in the coordinate planes. When we have translations in the coordinate planes, we look at our x and y values. We must always remember that the x value comes first and the y value comes second in a coordinate. In order to shift something horizontally, we will add a to our x coordinate. So, when we want to move something to the right or to the left, we will add a to the x value. In order to move it to the right, we will add it, and in order to move it to the left, we will subtract a. Now, in order to shift something up, we must utilize the y coordinate. To move it up, we will add b, and to move it down, we will subtract b. Let's try and apply this information. Here we need to translate the red image 3 units to the right and 3 units up. Our first step is to determine the coordinates of each vertice, so each point or edge on the triangle. I have written each coordinate for each vertice here, and you can determine the coordinate of the vertice by first determining the x value, so that's how many places it moves to the right or to the left. If it's to the right, then it is positive, and if it's to the left, then it's negative. If it is up, then it is positive, and if it is down, it is negative. And this is always in relation to the origin, so it's 0, 0, right smack dab in the middle where the lines cross. Now, we have determined our coordinates of each point. We must now shift it 3 units to the right and 3 units up. In order to shift it 3 units to the right, we must add it to the x coordinate. And it must be added because it is to the right. So we would add 3. To move it down, we need to utilize the y coordinates. And because it is down, we must subtract 3. So we're going to do that for each of our points. Here I have added 3 to each x-coordinate and subtracted 3 from each y-coordinate. We can see that here with this first point, as I have added 3 to 1 and subtracted 3 from 2. So now we can write our new triangle based on these points here. Now I have plotted these 3 points, and now all I must do is connect the dots. And that gives us our new image. Now let's try another one. This one has not yet been plotted, so we must actually plot our figure. I have done this now for you, and so now all we must do is actually connect the dots. And then our next step is to determine what our new image is going to look like. This needs to be 4 units to the left and 4 units up. Since it is 4 units to the left, we must utilize our x value. And because it is to the left, we must subtract 4. And then to go up, we will utilize our y value. And then we will add 6, as seen by our notes here. So, let's go ahead and we'll show the steps of how you must subtract 4 and add 6 to each point. I have went ahead and I have subtracted 4 from each x value and added 6 to each y value. This gives me a new square with new vertices, and the new vertices are given in the blue column. Now that we've found these new points in the blue column, we can go ahead and plot our new figure. Now that we've plotted these points, we can go ahead and draw our figure. And that's all we have to do. Now let's move on to reflections. Reflections are a transformation in which a figure is flipped across a line, which is called the line of reflection. Here we see that the red image is flipped across this line to create the blue image. Let's go ahead and do some examples. Tell whether the blue figure is a reflection of the red figure. Here we see that the red figure can be flipped to form the blue figure. So therefore, this is yes, because we see that the image is flipped. Let's move on to the next problem. Here we also want to tell if the blue figure is a reflection of the red figure. We see that there is some difficulty because this is not actually flipped. Because if it was flipped, then instead we would have the image pointing in the opposite direction. This would actually be a flipped figure. So since it's not pointing this way, we would say no, because this image is not flipped across the line. This example, I want you to answer on Edpuzzle for the question. If you put no, you would be correct, because if these were a reflection, then we would have it pointing in the opposite direction. So this red image would be pointing downward instead for it to be a reflection. Now we're going to talk about reflections in a coordinate plane. To reflect a figure across the x-axis, we need to take the opposite of the y-coordinate. And to reflect the figure across the y-axis, we need to take the opposite of the x-coordinate. So in math terms, a reflection across the x-axis is going to be the negative of the y. And a reflection across the y-axis is going to be the negative of the x. We're going to try an example of this. But this part boxed in here is very important, and I would box it in your notes so that you know this is something that you must study. Here's an example. Let's try an example. Here we have a triangle that is given by the coordinates of -1, 1, -1, 3, and 6, 3. We need to first draw our figure. Here I've drawn in the points for A, B, and C, and now we must connect the dots. Now, we want to reflect this into the x-axis. So, remember that to reflect something across the x-axis, we take the opposite of the y. So, for each y value, we're going to take the negative of it. So, our 3 would change to a -3, our 1 would change to a -1, and our other 3 would change to a -3. We would now plot our new points, which I have just done for you, and then we connect our dots. And we see that the coordinates of the image, so of the red image here, are going to be A is equal to -1, -1, because only the y value changed. B is equal to -1, -3. And C is equal to 6, -3. And all these, we see that we only took the negative of the y value to do a reflection of over the x-axis. Now let's try one where we're doing a reflection over the y-axis. Our first step is to plot our points. Now we need to connect the dots on our image. And then, in order to do the reflection across the y-axis, we need to take the negative of the x, as we see here. So that means our points change to A. So then we see all of our x values change from a negative to a positive, or a positive to the negative, whichever is the opposite. And now we have to plot our new points. Once we've done that, we can now just connect our dots. And we see now this is a reflection across the y-axis. For further assistance, read pages 50 through 52 and 56 through 57. Your homework problems for tonight are on page 52, problems number 4, 5, 10, 12, and 17. And on page 58, problems number 4, 6, 7, 10, 14, 19, and 20. These problems must be completed before class in order to receive full credit. Also, your video notes should be completed while watching this video. If you did not do so, go back and re-watch the video and complete the notes in your packet. These homework problems are essential to your learning. So even if you watch this video late, make sure you complete these homework problems so you can gauge your understanding.